This is a video about algebra and concepts that we'll need in order to study algebra. The first thing that we need in order to study algebra is the definition of a variable, or the idea or concept of what a variable is. So first of all, a variable in algebra is just a letter that represents a number or a quantity. X is the most commonly used variable. X is an unknown. It can be a number, it can be used in place of a number, or it can just simply be a value that could be represented by a number, but it's currently just being used to represent an idea. Algebraic expressions are sums or differences of variables, numbers, or the products of these. What I've shown here are some examples of algebraic expressions. This first one is a really simple, basic idea of an algebraic expression. It's just a number multiplied by a variable. The second one, this one is a little bit more complicated and is a number plus a number times a variable. In this algebraic expression, we have what we call two terms. Terms are things in an algebraic expression that are separated by addition or subtraction. So one term is the number here, 2, we call that a constant, and the other is a numeric coefficient. That's what we call a number multiplied by a variable here. So the third expression that I've shown here, this one is more complicated yet. This one has 1, 2, 3 terms. You see one subtraction here and one addition here, which separates this first term, this second term, and this third term. The first term is a variable times a variable. The second term is a number times a variable, and the third is just a number. This very last algebraic expression is by far the most complex algebraic expression. This one we see a term here, a second term here, and a third term here. Now this one might confuse you because here's some addition in here. And I said addition is what separates these terms, but this addition is inside parentheses, and so it's like a present all wrapped up and you can't see it. So that makes this a single term. So those are some ideas of what algebraic expressions might look like. And algebraic expressions are what we learn to deal with for the very first time in algebra. So we're going to talk about simplifying these algebraic expressions. So simplifying, what does that mean? Well, simplifying an algebraic expression means that we are going to make all the terms that have the same variable, we're going to make them all combined together. So all parts / terms that have the same variable are going to be combined, and combined means added together. There are not going to be any products other than that of a number times a variable or a product of variables. Now a number times a variable, that number that's multiplied by a variable, it has a special name. It's called a numeric coefficient, or just simply a coefficient, and that's not going to be a concern for us. So let's think of how we talk about things in the real world and then apply that to algebra. So let's think of this. I have 2 crayons here and I have 3 crayons over here. So if I held up 2 crayons to you and 3 crayons to you, and I said, okay, how many crayons do I have? You'd say I have 2 crayons plus 3 crayons. That means I have 5 crayons. Well, here I'm going to apply the idea of a variable. I'm feeling lazy. I don't want to write the word crayons, so I'm just going to write crayons with a C, right? Just make it simple. So I write 2 crayons as 2C plus 3 crayons as 3C equals 5 crayons as 5C. And that's how we do it in algebra. Just think of a variable as representing something that can be an unknown number, or it could simply represent a value of some sort. And that value of some sort definitely could be a number. Now, in this case, it has just a meaning to it, but that's okay. It can go either way. So this is how it would look for algebra. If we had 2c's plus 3c's, we have 5c's. And that's simplifying an algebraic expression. So now let's talk about an idea called like terms. So like terms, that means that the variable part of a term is exactly the same. So let's take a look at this. Sally has some fruit and John has some fruit. So Sally has 3 apples and 4 blueberries. And John has 5 apples and 5 blueberries. So with that idea that I came up with before about representing things in a lazy way, right? Apples, I'll use an A, and blueberries, I'll use a B. Sally has 2 apples and 4 blueberries. John has 5 apples and 5 blueberries. So if we wanted to talk about how many apples and how many blueberries that they had all together, we would say, well, Sally has 2 apples and John has 5 apples, so together they have 7 apples, right? And now let's talk about the blueberries. Sally has 4 blueberries, John has 5 blueberries, so together they have 9 blueberries. So we could say together they have 7 apples and 9 blueberries. So you see what we get is an expression that contains the values for the A's, the apples, and the values for the blueberries, B's. We don't want to chuck them together, they're different. So what we see here is like terms in the apple terms, the A terms, and like terms in the blueberry terms, the B terms. And you see here, we don't want to put them together. We're just going to say, okay, here's our apple terms, here's our blueberry terms, and we symbolize that we have both of these with the addition symbol. And that's how it goes in simplifying an algebraic expression, because we want to keep unique things unique. We want them to say, okay, I have some of these and some of these. Not all together though, because they are different. So now I want you to try just with algebraic expressions here. So I want you to try this first one here with 5x plus 2x, this second one here with 7y minus 3y, this third one here with the very complicated 7xy plus 6x plus 1xy minus 4x, and then I got really complicated on you, and that's why I've starred this one as xyz plus 3xy plus 2x minus xy. So why don't you pause your video and see if you can do this on your very own. All right, so hopefully you've given it a try on your own and you can see here what's going to happen. So if I have 5 x's and I have 2 more x's, I have a total of 5 plus 2, which is 7 x's. And that's the simplified version of 5x plus 2x. Let's do it again. I have 7 y's and I want to take away 3 y's. So 7 take away 3 is 4, and I have 4 y's now. Next, I have a little bit more complication. Now on this time around, what I'm going to do is I'm going to show you which ones I'm looking at together, right? I have xy's and xy's here. And I have x's here, and I have x's here. So this says I have 7 xy's, and I have 1 more xy. 7 plus 1 is 8, and those are xy's. And then I also have, and so I'm going to say also have as a plus here, I also have 6 x's, and I want to take away 4 x's. So 6 minus 4 is 2 x's. And that's as good as it gets, because I want to make sure that everybody knows that these things are different from these. So I say I have these and I have these over here. Now something I want to talk about is what I did here. This 7xy plus this 1xy, what I'm actually doing is the commutative and the associative property there. I'm commuting in my mind, saying I'm going to put these 7xy's and this 1xy together. And associating them means that I'm putting the terms and together in a group that I'm going to add. And then I did the same thing with these two x terms, commute and associate. And technically, we're even getting the distributive property in this simplifying algebraic expressions because it's actually doing the distributive property backward. And that comes a little later where we can show that. Now this last problem that I have here, this one's the most difficult because number one, you have to realize that if you say XYZ, it's just like saying pin. If I have a pin, what is a pin? Well, there's one pin, right? So technically, you can write the number 1 right out here. This one over here as well, there's one XY term. Now these can be also a little bit tricky as well because I've got parts that are the same, right? I have XYZ and this is XY. Well, the XY is in here, but these are not the same types of terms. Just like this X is in here, but these are not the same kind of terms. So the XYZs, I only have this one XYZ. So I'm going to write down here that this is XYZ. Now, if you prefer to put one XYZ, that is okay. That is the same thing. And then I'm going to look for XY terms. And I have two XY terms, one here and one over here. So in my mind, I'm commuting and associating. I have 3 of these XYs, and I want to take away one XY. So that means I still have, I still have 2 XYs. And then finally, I get down to the lonely 2x term. And there are no other x terms, so I'm just going to say, and I have 2 x's. So remember that every time after we pass from one type of term to another, we have to put in the addition symbol to say, okay, I have this many of these type, and this many of these type, and this many of these type. So hopefully that went well for you. I think that's it. Yep, that was the last thing in this one. All right, so the next video that I'll do on this will get into more complicated things, but that is the very, very basics of algebraic expressions and how we can simplify algebraic expressions, which is one of our very important skills in algebra.